In high school, we were told that the square root of a negative number cannot be defined or is invalid. Also, we were told that the division by zero is undefined, which all these I call them the math nasties. I talked to Professor Fazal Mohamed, who will tell me more about all these math nasties. Thank you, Prof.
Thank you.
All right.
Thanks.
Well, Prof, what I would like to know is, what is the square root of negative 4?
Yeah. Okay. Easiest way to explain this is, if I want to look at the square root of a negative number, say minus 4, how do I make sense of this? Right? Now we know that square root of 4 is equal to 2, right? If you take this as a positive. But also, in other words, if I multiply 2 by itself, it's going to be 4. But I also can multiply minus 2 by itself, or square of 2, is also going to give me 4. So the question is, I cannot get any real number which is the square root of minus 4. There's no real number.
There's no real, okay.
So therefore, the need to extend this. And one of the ways in which this has come out is when you want to work out a solution of this, right, x squared equals to minus 1. So one way is just to define I is equals to square root of minus 1. And then we extend the real numbers by a plus ib, where this is the imaginary unit.
Okay.
And then this here. This is a superset. If I put b equal to 0, this will contain the real numbers.
Okay.
If I put a equals 0, you only have imaginary numbers. And this is called the complement.
Okay.
And when I do this here, then square root of minus 4 will be square root of minus 1 times 4. This will be square root of minus 1 times square root of 4. So this will be I, and then this will be 2. Right? And if you want the plus or minus, you can add plus or minus.
But Prof, why was in high school, why were we taught these things about?
Yeah, I think each stage, even when mankind evolved, people try to avoid solutions of this here. Right? And even when people try to even avoid square root of 2, which is irrational number, right? Yes. And that comes up from looking at isosceles triangle here, where this is square root of 2. 1 squared plus 1 squared equals to 2 square root of 2, this length here. People try to avoid this. And people also try to avoid this. I think in the evolution of mankind, and even when we have looked at where people in school students have, for development of school students, they try to avoid throwing such things and said, because they didn't want to introduce the superset.
Okay. But we talked about imaginary numbers like I.
Yeah.
I. And this imaginary number applied in real life, can you apply it in real life? And where can you apply it in real life?
It's not, in a sense, directly applicable. Yes. However, it simplifies calculations in solving partial differential equations. And you can represent entities using complex numbers, and you can obtain the solutions to real world problems. Okay. And this is used quite often in fluid mechanics, which is very relevant to us today. Also in quantum mechanics, which is mechanics of small subatomic particles, small particles. So one can use complex analysis. And also some of the results in the complex plane, or in complex analysis, extension of real analysis, is simpler, and they are beautiful results. And the way mathematics has evolved is when you try to solve such problems, you develop and develop, and people have used. It was unthinkable that people said that algebra will not be used. Yeah. Right? And today, without algebra, we can't get anywhere. Right? And I like that with complex analysis. I think without complex analysis, mathematics will be poorer, and also the way we use mathematics will be poorer for applications for real world. Yeah,
there's a formula that we use to calculate the two radius, these two pi radius, the one we use to calculate the circumference. What I'd like to know is, how did this one come about? How did the pi come about?
Now pi is a very interesting and exciting number.
Yeah.
And the value of pi today is known to some billions.
Yeah.
Of
It's
decimal
known as
places.
22 over
Yeah.
7. How do you?
Well, the 22 over 7 is not the exact value of pi. It's an approximate.
Yeah, that's what
It's
I
more
want.
or less what people use in high school, and even when you want to get away with some crude calculation. However, pi is a transcendental number.
Okay.
It's a godly number, if you like. It goes on and on and on. One of the approximations used in school mathematics is 22 over 7. Now, one of the ways in which people have pi is circumference over diameter, because 2r is diameter, right? The d is 2r. So the ratio circumference of the diameter is called pi.
Mm-hmm.
One can do experiments.
Mm.
You can you take a circle, work out the circumference of the circle,
Mhm.
different circles, and work out the diameter, and try to calculate pi, right?
Okay.
And depending on how good your calculations are, you'll find some value of
The
pi.
same pi has no static answer. I mean, it's different
Yeah.
during time.
Yeah, and in fact, in the ancient times, pi
Yeah.
was just 3.16, 3.15.
It's not to be a big number. Like
Yeah.
in high school, it's a big number that, okay, one can say it's not, it cannot be big.
Yeah.
Okay, to you, what is infinity?
Precisely what you said. In simple terms, it cannot be reached. If I sit on the real line, right, I start at 0, right, and I go to the right as far as possible.
Yes.
If I travel and travel and travel billions of years,
Yeah.
right,
It's,
it's still beyond that.
but can't infinity be a number? I mean, just
In calculations,
Yes.
yes. In
How?
calculations, what people do is when they have 1 upon 1,000. These kind of things, whatever a very large number is 0, or when you have even infinity can in certain kinds of fluid problems you can reach 0 or infinity in very quick time in computer time, right? For practical purposes, you can reach infinity even up to 8 or 10, depending on what the problem is. When you do computer analysis, computational mathematics. So you can reach infinity quickly, right?
Okay.
Like for example, even in a graph,
okay, so you have to define your own infinity.
yeah, you can define your infinity can be reached here, somewhere even here, or say 10,
Okay.
right? In practical problems.
Mm.
However, in mathematics, infinity cannot be reached. Okay, the symbol for infinity is the line down 8.
Okay. Why is 0, I mean, a number over 0, undefined? I mean,
Yeah, I mean, if I take
maybe 2 over 0. We were told in high school that this is undefined.
yeah, because 0 times there will be no unique number that gives you 2. If I multiply anything by 0, I'm not going to get 2. If I divide 10 by 2, it means it's 5, because 10 is equals to 5 times 2.
Okay.
Right? Now, and you also get this indeterminate form. 0 over 0 is the indeterminate form, right? This is also undefined. But in calculus, when you have functions, limits of functions, it could have certain finite values, right?
Okay, so it's because there's no number.
0 does not have a multiplicative inverse.
Okay, yes.
So in other words, there's no number, no unique number.
Yes.
In this case here, there are many numbers,
Yeah.
which will be 0 times, there will be many numbers that will be here. So it's not unique here. In this case here, for the indeterminate form. In this case here, there's no number that will give you 2.
Okay. Okay, but there's no other way of, I mean, in your complexity of mathematics, it cannot be proved that there's no number that can be divided by 0.
Yeah, look, in higher mathematics, you can.
Yeah, I mean, higher mathematics.
No, even then too, you can start talking about partitioning and trying to understand these things and go beyond.
Yes.
And then beyond, and when you talk about 0 divisors and so on. But in algebra, in abstract algebra, for example, but as we know it, you cannot do these.
Okay. Well, there are engineers and mathematicians. You find them looking at things in different dimensions, like in 3 dimensions, which we know, and sometimes in 4 dimensions. So how can one look at something in a different dimension? How can one visualize something maybe in a dimension that is greater than 3, which is 4, or 5, or 6, or 7, which in real life people don't really, in high school it's very differently.
Yeah.
You're told there's a 4-dimension thing, it's different. How can one visualize that?
You cannot, you can perceive of it, or you can do projections to try to understand or appreciate or perceive what will be in higher dimensions. If I have a triangle, for example, a equilateral triangle on the plane, it's a planar object, right? Now, if the triangle, it will have a median line, right? If I want to look at the triangle will remain the same if it reflects itself about its median line, right? But another way of looking at that as a 3-dimensional thing is, if I flip the triangle around, I'll get the same effect of the mirror symmetry of the equilateral triangle. But the triangle cannot feel that. Right? I as a 3-dimensional can feel that, right? And like that, if I can go to 4th dimension, I can take my left boot and rotate it in higher dimension and make a right boot, if I could do that. Right? But I cannot, because I'm a 3-dimensional being, right? But in mathematics, there's a need for going higher dimensions. You have n tuples.
You can have
more dimensions. But also there are physical theories that use higher dimension. Relativity is use 4-dimensional space-time, where the extra dimension is time, not space. However, in pure mathematics, you can have those extra dimensions to be space. You can have 4-dimension, you can have 5-dimension, and so on. You can generalize. And in string theory, you have higher dimensions also in physical theories and string theory, the general relativity. So each point in space is different because of time, right? Compared to Newtonian space, where you have absolute space. In relativity, the space is not absolute. Each point in space is attached with a time point.
Okay, thank you very much for joining us on this.